Plovdiv, Bulgaria. One of the oldest cities in the world and the oldest living city in Europe is getting ready for a giant leap in the field of science. Plovdiv is facing a bright new bio-horizon to reach. And that is plant assist. Meet the partners and picture their horizons.
I'm Dr. Ramadoss Dhanushkodi. I come from India. I did my PhD at Mass University, New Zealand. My PhD was in plant biology, where I did identify the novel genes that shows the nodule senescence in model legume, which is a Medicago truncatula. After my PhD, I joined here as a postdoctoral researcher in the field of molecular plant stress physiology. I am now working with Ramadoss Dhanushkodi, which is the model legume. This is the model plant. It's called Ramadoss Dhanushkodi, where we do all the research in this plant actually. This plant is now mutated. One gene is mutated, which is a novel gene that shows oxidative stress tolerance to most of the abiotic stresses. Now I am working in this plant. Now I will grow this plant under water deficit condition, and then I will see this plant is showing high tolerance to the less water condition than the wild type plant actually. Where the gene is mutated in this plant shows the oxidative stress tolerance. This plant gene is already identified, but the function is unknown. I am working on identifying the function of the gene which is there in this plant mutated. I will then identify the same homologs of the gene in other vegetable crops such as tomato, cucumber and eggplant. I will then see if the gene has the same effect in the other vegetable crops or not using various gene technologies. I found that the gene which was identified here shows the oxidative stress tolerance, that I grew the plants under water deficit condition, and I found that this plant carrying that gene mutated showed tolerance to the water deficit condition as compared to the wild type plant where the gene was not mutated. Also, I also found that overexpressing this gene reduced the resistance of water deficit conditions. I also found that the homologs of the gene, that means the same gene also found in other vegetable crops like tomato, cucumber, eggplant, Chinese cabbage and lettuce. So I have found all these genes in those vegetable crops. The major application of this gene is to transfer the same technology to the other vegetable crops, like I said, to see if this gene has the same function in all those crops or not. If this gene has the same function in all those crops, then we can produce the vegetables where this gene is mutated. Then the application and the output will be with these vegetable crops can withstand even under very even under very low water conditions. So this is the application of this gene, and I'm taking this gene technology to these important vegetable crops because the vegetable crops are the important for the agriculture and economically important for this country and the whole world.
CPSBB is meant to unite scientists from all over the world, a true crossroad of cultures over the centuries. Plovdiv is determined to be the newest crossroad of science in the near future. Plovdiv is facing a bright new bio-horizon to reach.